Hello guys, welcome to this video. In this video, I will show you how we can implement custom website chatbot. So many people has asked me this question, sir, how we can implement our own custom website chatbot. Okay, let's say I have one website and I want to create a chatbot on top of that. So let's say if anyone is coming to my website and they're looking for something in my website, they're asking anything related to my website. So my chatbot would be able to give the response. Okay, so this is a kinds of RAG based system guys will be developing, because here the data will be using our website data. We'll try to connect the website data to the model, so that model can refer that particular data as a knowledge base. Okay, so this system will be creating with the help of LangChain. So we try to use the LangChain, and here one amazing thing I'll show you how we can use the open source large language model, okay, instead of using the paid one. So far we have used OpenAI model, I think you saw that, but if you want to use any open source model, you can also do it, okay, from the Hugging Face itself. So again, I'm telling you guys, here you can use any kinds of model, it's up to you. I'm going to show you with the help of let's say open source LLM. So here I'm going to use like Meta Llama 2 model. You can also use Llama 3, Mistral, okay, OpenAI, anything you can use, anything you can replace here. Okay, so first of all, I will show you how we can use these kinds of open source large language model with the help of LangChain. I will show you one demo. Then after that, we'll start the development of our custom website chatbot, okay, step by step. So this is going to be one amazing development guys, so make sure you are watching till the end, and I think you will be enjoying a lot. So let's start guys on the development. So guys, notebook is connected. Now, first of all, let's see whether I got GPU or not. So this is the command to check the GPU. So here I got Tesla T4 and here I got 15 GB VRAM. Now what I need to do guys, I need to install some of the libraries. See guys, if you're using any open source large language model, okay, open source LLM model, which is available in Hugging Face. So for this actually you need to install this transformer library. Okay, so using this transformer library, we can actually access our Hugging Face model. Okay, so that's why this transformer library we need to install. Then I need to also install, these are the two libraries, Accelerate and Anops. Then I need also LangChain, because here I'm going to use LangChain. Okay, and this bytes. Okay, so these are the package actually I need to install. So these are the actually dependency. So LangChain I need because I will be running these are the LLM model, Hugging Face LLM model, with the help of LangChain. And I also need transformer because I will be using my Llama 2 model from my Hugging Face itself. Okay, that's why this transformer is required. Now let me install. So guys, as you can see, installation is done. Then first of all, what I need to do, I need to log in with the Hugging Face account. Okay, so to log in with the Hugging Face account, you need to use Hugging Face CLI to log in. Okay, so here you just need to give the API key. Okay, Hugging Face API key. So there is a secret key actually will get from your Hugging Face account. So let me open with my Hugging Face account. So guys, this is my Hugging Face account. If you don't have any Hugging Face account, just try to create one account. Okay, now if you click on the profile and go to the settings, and here you will get one option called access token. Okay, just click on the access token. So here previously I already created one access token here, so I'll be creating a new one. So you can also create a new access token. You can give any name. So let's say I will give as Llama, and you can get read and write permission. I will be giving read permission because I only want to read the model from here. Then I'll just generate a token. So this is my token guys. Now what I will do, I'll just copy this token. And guys, don't share this token with anyone. Okay, otherwise they will also able to access your account. So I'll remove this token after this recording. Okay, that's why I'm showing. Now let me execute this command, and it will ask for the token. So just click here and paste your token and just press enter. So if you do it, so now it will tell add token as get credential. So what I will do, I'll just give yes and press enter. Now guys, here if you see my logging is successful. Now what I will do, I will import then I need to import this Hugging Face pipeline from LangChain, langchain.llms, because with this Hugging Face pipeline, so with the help of this Hugging Face pipeline class, I will be loading my large language model, which is nothing but my Llama 2. Okay, so I need to import this library. Then I also need to import Tokenizer. So what is Tokenizer guys? Tokenizer is nothing but it is responsible for pre-processing the text into arrays of number as input to the model, because so whenever I will be giving any input to my model, it would be completely text input, right? but my model can't understand that text, raw text actually I'll be giving. So for this actually what I need to do, I need to convert to numbers, right? Even I also need to perform some pre-processing. So everything can be performed using this tokenizer, okay, auto tokenizer class. So that's why I need to import it. Then I also importing transformers, then torch and these warnings. Okay, now let's load our Llama 2 model from this Hugging Face. So as I already told you, so you will get these kinds of access once you got the access and all. Okay, so I have already added some screenshot here, and once it is done, it will tell you this message, right? Now here guys, you need to define the model actually you want to use. So in this case, actually I'm using this model. As I already told you, I've just copied this name and just paste it here. If you see, this is the complete name I have given. And this is the model from Meta, because this is the official model actually I'm going to use. And this model I need the permission. I think I already told you this model I need the permission. But let's say if it is taking for you to take the permission and all. So what you can do, you can use this model. You just comment this line and uncomment this line. So this is the same model, but this is present in the public repository, and this access is given to everyone. Okay, so you can easily use this model, and this is the same model guys. Okay, this is the same version of the model. So what this guy has done actually, so he has cloned the official version of this Llama 2 7B chat agent model, and he has published in his you can say repository here, and this is completely completely public access, so you don't need to take any access okay from this author. So you can easily use this model. So let's say if you have applied for the access and it is taking time and you want to do it right now with me, so what you can do, you can uncomment this line and you can load this model. Okay, but for me I have already access to my official model, so I'll be using official model and I will comment it out. Okay, so it's up to you which model you're going to use. Now guys, first of all, what I need to do, I need to load my tokenizer. So to load the tokenizer, you need to give the same model name. Okay, so with respect to that, it will load the tokenizer. Now here, what you need to do, you need to create one pipeline objects, and here you need to call this transformer pipeline. Okay, and here you need to give the pipeline name. So here I have given text generation, because if I go to this model I'm using, so this is a text generation model. As you can see, this is a text generation model. So that is why I have given text generation here. Now I also need to give the model, like which model I'm going to use. So this is the model I have given here. Okay, then I'm also need to give the tokenizer. So this is the tokenizer I have given, and these are the parameters. Just keep it as default, and this is the maximum input length. So I've given 1000. You can also increase and decrease the size. Okay, it's up to you. Now guys, what I will do, I'll just quickly load my pipeline. So basically it will load the entire pipeline. It will load your model, it will load your tokenizer, everything it will load as a pipeline. So what is the use of this pipeline? Pipeline means, like, first of all, whenever you are giving any input to the model, first of all, it will apply the tokenizer and it will convert that text to numbers. Okay, it will pre-process the text, then it will apply this data to the model. Okay, so that's why this pipeline handles each and everything. You don't need to write any custom code for it. And now guys, here if you see, it is downloading the model. Okay, and I'm using free collab, and I got 15 GB VRAM there. So I think you can see RAM is not utilized till now because it is downloading the model. So once it will load the model, it will utilize my RAM. So guys, my model has loaded. Now what I need to do, I need to call this Hugging Face pipeline. I think you remember we load this Hugging Face pipeline from LangChain. Okay, here if you see from LangChain .llm, so we load this Hugging Face pipeline. Now I need to give this pipeline object to this Hugging Face pipeline from my LangChain. So here you will get two parameters called pipeline. So here you just need to provide the pipeline. Okay, this pipeline we have created. And another keyword you need to give the temperature value. So what is temperature value? So see, I think you already know like what is temperature value. So here I've already written. So temperature value, like so if it is 0, that means the model is very safe and it is not taking any bets. And if you are giving this and if you're setting this value to close to 1, so it will be taking risk. Okay, and it might generate wrong output, but it is very creative. So this is the parameter actually you can change. Let's say if you want some stick output from your model, okay, you can set this parameter as close to 0. And if you want, let's say, very creative results and you are not worrying about the wrong output or let's say random output, so you can give this parameter as 1. Okay, so this is the parameter you need to give. So here I want streak output from my model, that's why I set this parameter as 0. Okay, so this is the parameter I have given. Now here I'm defining as LLM. So this is my large language model. Okay, but I think you remember initially I was using something called OpenAI large language model, which is nothing but GPT 3.5 Turbo. You can use anything, GPT 3, GPT 4, anything you can use. But there actually I was using OpenAI API, and it was taking charge for me, right? But this is completely free. Now see, with the help of these kinds of open source large language model, and it is also available inside Hugging Face. We have easily loaded this model, okay, and we have created our LLM object here. Now this is one prompt actually I have prepared. So what would be the good name for a company that makes colorful socks? So this, let's say this is my prompt. This is the user prompt. This is the user input, and it is giving this input to the LLM. And now let's see like what LLM will predict. Okay, so here I will give this prompt to my LLM, and let me execute. You can also set your custom template, prompt template. I will tell you like how to set it. But first of all, let's give my prompt without any template, because by default your LLM will have some custom like you can say default template. It will use that template. So guys, here is the response I got from my Llama 2. So I would suggest the following names for the company that makes colorful socks. So Sol Mats, Hue and Cry, Tall, Tally, Socks. Okay, it's great actually. Even it is giving also the description with respect to the name it is suggesting. Now you can give any kinds of prompt, you can check it out. So let's give another prompt. So here I have given, I want to open a restaurant for a Chinese food. Suggest me a fence name for this. Okay, so you can also give, let's say, Indian food. Okay, I'll give Indian food. Now let's see whether it is giving me some name or not. So I'll execute my LLM. Now guys, as you can see, it has given me the name. So restaurant, I would suggest the following names for your Italian, for your Indian food restaurant. So Tandoor Nights, then Spice, Rahut, Mumbai, Bazaar, Curry Leaf. Okay, so great. I am getting very good name. Let's see if you want to open a restaurant. So you can refer, these are the name, and these are the name is like very unique. Okay, and this is the description. Now also you can create your custom prompt. Let's say see, this is the better practice to create our custom prompt always. Let's say whatever task you want to perform with the help of your LLM, so you can give the custom prompt, okay, instead of using the default prompt. So to give your custom prompt, you need to import prompt template from LangChain first of all. So let me import, and I also need to import something called LLM chain, okay, from LangChain. Now this is the first example I have given. So this is my prompt template one. So here I've given the same prompt as I think you remember, and I've just written I want to open a restaurant for here I've given cuisines. Cuisine should be the input. Okay, here I've given this should be the input variable. Food, suggest me a fancy name for this. Now I'll be using this prompt template, and I will be giving to my LLM model. Okay, so it won't be using that default prompt template after giving it. Now let's say how it will work. So this is the technique it will work. So basically it will apply this format on top of it, and whenever it will get this cuisines, actually it will replace this input. Okay, the input I have given, let's say I've given Indian. Now if I print this input prompt, if you see I want to open a restaurant for the Indian food, search me a fancy for this. Okay, so this is the input I have prepared with the help of this code, right? Now let's take the second example. So this is the another prompt I have created, prompt 2, and here I'm using another prompt, provide me a concise summary for this book, and here I'm taking book name as input from the user. So how it will work, so whenever user will give any input, let's say I have given alchemist book. Okay, so it will take as input, and it will make the complete prompt. See, it will make the complete prompt. Okay, now let's use the first one first of all. So I'll be using this from template 1. So here just let me write. Now I'm going to use this prompt 1 at the very first. Let's use prompt 1, and here I have created LLM chain, and here I have given my LLM. Okay, so LLM model I have given, so which is nothing but the LLM we have created. I think you remember, this is my LLM, this is my LLM. Okay, and here I have given the LLM, and here I'm giving the prompt as my prompt template, and here I'm also giving verbose is equal to true. That means it will also print the log, like what it's doing actually. So if you're making it false, so you can't see the output log, and if you are making it true, so you can see the output log. Okay, now here you need to call chain.run, and here you just need to give the input. Okay, so here let's say I'm running this prompt 1, and this for the cuisine. So here what I will give, I'll give Indian cuisine. Okay, and this is the response I will get. Now let me execute and show you. See, first of all, it is entering to new LLM chain prompt after formatting. So this is the prompt it has prepared. So it has taken my input Indian, and this is the prompt actually it has created. Now it is applying LLM on top of it, and it will predict. Now let's see. Now guys, chain has been finished, and this is the response I got. A restaurant name is a crucial aspect of any business. Okay, and these are the name actually it is suggesting. Now what I will do, I'll give this prompt template 2, that means my book prompt, and here now I'll ask any book name. So let's say I'll give Harry Potter. Harry Potter book. I want the summary of Harry Potter book. Let's see whether it is able to give or not. And this model is pretty good, guys. Just try to explore this model. I am loving this model a lot. Okay, as an open source model, I can say like this is one of the best model you can use from Meta AI. So see guys, this is giving me the summary. Again, if you mention the book with a specific name, let's say it is giving the summary of Philosopher's Stone. Okay, you can also give any specific book. It will give you the summary. In that summary, it will give you. Okay, so great guys, we are able to use this Llama 2 model with the help of LangChain, and we have seen like how we can load this model with the help of LangChain and all, how we can create the template. Okay, how we can create the LLM chain and everything we have seen, right? So guys, I'm inside my whiteboard. So now, first of all, I will just write the project's name. So it is website bot using Llama 2. Okay. So here, let me give you the project's architecture, like how we are going to do the project. So first of all, what I will do, I need to collect those website sitemap.xml. Basically, I need to collect all the content, okay, from the website actually I'm referring. So first of all, we'll be taking all the content with the help of this sitemap.xml, okay, xml. And you don't need to worry about manually, you don't need to write these are the thing. Actually, if you're using LangChain, so with the help of LangChain, actually you can easily extract the content from any unstructured website. Okay, I'll tell you like how to do it. So what it will return, it will return so it will return you page, okay, page, let's say 1, page 2, and page 3. So after getting the page, actually I need to get the documents, okay, present in the page. So it will return me the documents. Let's say docs, okay, docs 1, docs 2, docs 3, okay, docs 4, and so on. So docs 4, okay, now it will return me that documentation, like all the page content. So once I get all the content, okay, basically here let me write out here, we are just extracting text, okay, extracting text. And after getting all the text, what I will do, I will use my embedding API, that means embedding model. So in this case, I'm going to use Hugging Face embedding model. I think you already know what is embedding model and all. I already discussed this thing in my vector database session. So if you haven't watched that session, you can go ahead and watch it. So everything would be clear there. So I'll be using embedding model. So with the help of embedding model, actually, I'll try to convert this text to vector, okay, vector representation. Now this will return me the vectors. So here I will get lots of vectors. Then once I get the vector, I will build semantic index. Okay, I think you know what is semantic index. Semantic index means you will be combining all the vector together. Okay, then you will be building the semantic index, and you will be storing this semantic index to the knowledge base. Okay, so what is knowledge base? Knowledge base is nothing but your vector database. So let's say this is my knowledge base. Okay, this is my uh, knowledge base, or let's say vector db. So these are the vector will come here. These are vector will come here, and it will store inside my vector db. Okay, so once I'm able to store, these are the vectors, okay, in my vector db. Now what will happen, let's say this is the user. Let's say this is the user. So user will hit some queries. So let's say this is the question from the user. So the first thing what I need to do, I need to convert these questions to the vectors, because again it's going to be the raw text. Okay, so again I'll be applying something called embedding model. Embedding model. Okay, then I'll convert this text to vector. So here I will get something called query embedding or query vector. So this query vector, I will apply something called semantic search. I think you already know what is semantic search. Okay, so semantic search on top of my vector db. Okay, so I'll do the semantic search. So once you do the semantic search, it will return you some ranked result. Okay, rank results. Now I will have my rank results. Now I will take the help from my LLM. I'll be using large language model, which is nothing but my uh, Llama 2. Okay, here I'm going to use Llama 2. So with the help of this large language model, I will get my actual uh, response. Okay, the query user has asked, so it will give me the actual response. Okay, so this is the complete idea, and this is nothing but this is my user. This is my user. Okay, so this is the complete you can say diagram of our projects. As you can see, first of all, we'll be using, these are the website. With the help of sitemap.xml, we'll be extracting all the pages available in the website. Then we'll be extracting the documents, that means extracting the text. After that, we are just converting, let me write here, converting text to vector vectors. Okay, here we'll be converting text to vectors. Then we'll get our vector embedding. That vector embedding will be building one semantic index and we'll be storing into the vector db. So in this case, actually I'm going to use something called Pinecone vector db. Okay, you can use any vector db, where you can use chroma db, you can also use face, okay, from Facebook, anything you can use, but I will be using Pinecone. Then what will happen, user will ask some query, I will be applying again embedding model, and I'll be getting query embeddings, and with the help of this query embeddings, I'll be do semantic search on top of my vector db. It will give me rank results, and with the help of LLM, I'll extract my correct output I was expecting. Okay, and it will give me the correct response to the user. So this is the complete idea of these projects. Now what I will do, and here I already prepared one notebook for this project. So I'll just explain like whatever things I have done. So first of all, I need to connect my notebook. Make sure you have selected runtime as GPU. So here just click change runtime type and select GPU. So for me, I've already selected. Now here I need to install some of the package. So here I'll be installing LangChain, then bytes and bytes accelerate transformers. Why we need it, I think you remember. I think previous experiment I was showing how to use Llama with the help of LangChain. Okay, and I was reading that Llama model from my Hugging Face, and for Hugging Face actually I need to install these are the libraries. Then these are the actually dependency you can install. Okay, then PyPDF should be another dependency, and also you need to install sentence transformer. Now let me install them. So installation is done. So here I'm not going to use OpenAI. So let me just delete this thing. Then I also need to install this library unstructured, because the website will be loading. So it has lots of unstructured format. So to overcome this thing, actually you need this package called unstructured. So let me install it. I'm not using Face. Face is again another vector database. So you can remove this thing. I'll be using something called Pinecone. So this is done. Then I also need to install tokenizers, then Xformers as well. Now I will be also installing Pinecone client, because here I'm going to use Pinecone vector database. And guys, if you haven't checked my vector database session, you can check it out. Okay, it is available. Otherwise, you might get some confusion. So it's better to try to understand this vector DB. Okay, then you will get the entire idea. Now, all the things I have installed. Now I'll be installing all the requirements libraries actually I'm going to use, and whatever libraries actually I'm going to use, I will tell you. Okay, which library actually I'm using for which purpose. Actually, I will tell you at that time. So here you can see some additional library also I'm importing, but again I will discuss like what are things actually I need here. Now I also need to install punctuation NLTK. So the first thing I need to collect some of the website URL. The website URL actually I want to use for my bot. So here I already showed you I am using this 4 website. Okay, I'm using this 4 website. You can use any of the website and you can use it. So these are the 4 website link I have provided inside one variable called URLs. Okay, now let me execute. Yeah. Now I think you already saw we have imported one class called unstructured URL loader from LangChain. Here if you see unstructured URL loader. So this class will help you to extract all the data from this or the URL. Okay, I think I was explaining this project architecture, like it will be using something called sitemap.xml. Then it will extract the pages. Okay, from the pages it will extract the documentation. So everything can be done with the help of this function actually we have imported here. Okay, unstructured data loader, and here you just need to give the URL, and it is not only working with the single URL, it will also work with the multiple URL as well. Okay, so now if I execute and show you, so it will easily extract the data, and it will go through all the pages actually this website has, and it will extract all the data for me. See, it has extracted. Now if I print my data, see guys, all the data you can see here. It is amazing, right? So that is the power of LangChain. So that's why we use this LangChain framework to build these kinds of generative AI application. Okay, now if I show you my data length, so it should be 4 because I'm using 4 website, so it will give you 4 website data. Okay, here. Now this data should be in a document format. I think if you see the format of this data, it should be a document format. Okay, and now I need to apply something called text split on top of the entire corpus I have, because I need to convert my data to chunks. Okay, why I need to convert my data to chunks? Because see, I think I already discussed this thing in my vector database session. Why this chunks is important? Because whenever you open any kinds of model, okay, let's say if I open let's say OpenAI model here, OpenAI model, OpenAI, or let's say if I open my Llama 2 model. So here if you see, it has context length as 4096. Okay, like it can take like 4096 tokens, okay, at a time. But if it is more than that, actually at the time, your model can't take this and it will give you error. Okay, but the data actually we have extracted, it has like more than 4096 you can say tokens. Okay, so that's why I can't directly pass this data. I can directly pass this corpus to my model. So that's why I need to convert to chunks. Chunks means I will be converting different chunks. Okay, different chunks means different paragraph. Okay, and that paragraph I will be converting to like embedding vector. Okay, then I'll be giving that data to my model. Okay, I already discussed this thing in my vector database session. Just try to go ahead and check it out. This should be very much clear. Now here I'll be converting my entire corpus to the chunks. So this is the character splitter function I have imported from LangChain. Here if you see, character splitter from LangChain I am importing. Now with the help of this one, I will be creating the entire chunks. Now here you need to provide two things: the chunk size and the chunks overlap. Chunk size means like how many tokens you need in a chunks, and chunks overlap like how many tokens actually you want to consider from your previous chunks. Okay, so these two parameters you need to give here. Now let me execute. Now my chunks object is created. Now I'll give my data. I'll give my entire data I got from my URL, and it will convert it to chunks. Okay. Now if you want to see the chunk size, so it has created 90 chunks. So if I print my text chunks, okay. So now let me show you. See, this is another chunks. Then again, this is another chunks. Okay, then again this is another chunks. That's how it has created 90 chunks. Okay, and if you want to see individually, you can also see this is the chunks 0, chunks 1, And if you just read it carefully, you will see some of the tokens are coming, okay, from your previous chunks as well. Okay, so this is the chunks overlap. So basically it helps us to understand the context of the sentence actually you have. Okay, now we have successfully converted our entire corpus to chunks. Now I'll be downloading the Hugging Face embedding, because here I was discussing I got my all the documents, okay, and I have converted to chunks. Okay, if you see, we have converted to chunks: docs1, docs2, docs3, and docs so on. Now I need to use Hugging Face model, Hugging Face embedding model, to convert these chunks into embedding, okay, vector embedding. So that's why I will be downloading first of all Hugging Face embedding. So to download the Hugging Face embedding, I think I already imported this library here. Hugging Face embedding, I think somewhere, yeah. So from LangChain embeddings, Hugging Face embedding. So it is available inside LangChain. Now here I'm importing. Okay, now if I execute, it will automatically download the default model. So Hugging Face has lots of you can say embedding model. So this is the one of them. Okay, so this is the name I have already given. You can open it up. So this is the model for embedding. Okay, so you can read about this model. I have already downloaded this model, and now let me see the model, which model I got here. So here if you see, I got something called sentence transformer all MPNet base v2. This is the model I got. Okay, this is the embedding model. Now if I, let's say, if I want to convert any text to embeddings, okay, and I want to see like what kinds of vector and what is the length of the vector, so I can test it. So let's say I have given hello world, and from the embedding I'm just doing query embedding. Now see guys, the length should be 768. Now this is the vector representation of this sentence. Okay, this is the vector representation of the sentence. So you can give any here. So let's say I'll give hello, or let's say how are you? How are you? And I have explained this thing detailedly in my vector database session. So that's why I'm again and again telling you, just go ahead and try to check it out, that video. It should be very much clear. See, again, I'm getting the same length, like 768. And this is the how are you vector representation. Okay. Now what I will do, I will initialize my Pinecone vector DB. So for this, actually, I need to collect two things. One is like Pinecone API key, and it is like Pinecone API environment. So for this, I need to visit first of all Pinecone. So just write pinecone.io, and here make sure you have the account. So I have already account, so I'll just log in with my account. So guys, if you log in with your account, so you will able to see this kinds of interface. So first of all, you need to get the API key. Just click on the API key, and here is my API key. I have already created. So what you can do, see, this is my previous API key. I will just copy this API key, and if you don't have API key, just create it here. Okay, just click on create API key, give the name, and create the API key. Will get your API key. Then I'll just paste this API key here. So this is my API key, and don't share this API key, guys. I'll remove this after this recording. That's why I'm showing. And I also need like a Pinecone API environment. So for this, actually, you need to create one index. Just click on the indexes and create an index. And you need to give the name of the index. So let's give Llama projects. Llama or you need, let's give Llama, only give Llama. Okay. And here you need to give the dimension of the vector. So this is the dimension actually. So here I'm using Hugging Face embedding. So Hugging Face embedding, this is the dimension 768. So this dimension I have to give it 768. And I will take this cosine metric. Okay, so you have any other metric as well, so I'll use this cosine metric, and because here I'm using free plan, then I will create the index. So it will take some time to ready your indexes, so let's wait. See, once it is done, it will give you this green icon. Now here you will get this environment name called GCP starter. Okay, I will copy this name, and here I need to give it. Okay, done. Now let me execute. So I have set my environment, so API key and API environment. Now I'll initialize my Pinecone. So here, instead of giving inside your ways, you can give it directly. It is also fine. So let me just give it directly. So that's how I can provide. Now let me execute. And now I'll give this credential, and I will just initialize my Pinecone. And here you need to give the index name you have created. So this is my index name, which is nothing but Llama. I'll copy, and here I'll just give the name. Okay, and this particular line will convert your entire like chunks to the embedding, vector embedding, and it will store inside the Pinecone. See, this is the code. Basically I have my text chunks, and one by one I'm just reading the content, and I'm using my embedding. Okay, and I'm converting to vectors, and index I'm giving also, like this is the index, like this is the index I have created. So in this index actually your vector will store. Now let me execute and show you. Done. Now if I go to my Pinecone and refresh the page, you will see like all the vectors actually. Okay, see, this is my text with respect to that. This is my vectors. Okay, this is the vector representation, and this is the index. Okay, and now see, we have successfully stored our data. We have successfully stored our vectors to the vector database. Okay, and you can see all the vectors here. Okay, you can also query out everything you can do, and this thing you can learn from my vector db tutorial. So there actually I have showed you like how to use this vector db and all. So here I'm not going to explain in depth, okay, because they have already explained this thing. Now see guys, I already stored my vectors inside my vector db. Now what I will do, I will first of all logging with my uh, uh, logging with my this one, my Hugging Face, because I want to use that Llama 2 model from Hugging Face. For this actually I need to log in. So let me log in. So if you want to log in, you need this access token. I think you remember I was collecting the access token. So this is my access token. I'll just copy. You can create your access token. Okay, I think I already showed you how to create it. Now here I just need to give the token and log in. See, logging successful. Now here you need to specify the model name, which model you want to use. I already told you I'll be using this Llama 2 7B chat HF model. So this is the model name I've given here. And you can use that alternative also. Like let's say if you don't have the permission, you can use that model, that open source model. I think previous experiment I was showing, okay? Because I already have the access, so I'll be using this model. Now, first of all, I'll load my tokenizer and model. I already discussed like what is tokenizer and model. Okay, why I'm loading? Because I want to create the pipeline. Now let me load it. See, it is downloading the model. So it will take some time. Let's wait. So guys, we have already downloaded the model. Now we need to create the pipeline. I think I already showed you like what is pipeline and all. Okay, why we need it. So now let me initialize the pipeline. Okay, so here if I show you my diagram, so we have completed till this point. Actually, we have stored the data. Now we are initializing our LLM. Okay, then we'll be handling the user. Now pipeline has been initialized. Now I'll be calling this Hugging Face pipeline, and inside that I will give my pipeline objects, and I will also give this argument called temperature. I already told you what is temperature. Now let me initialize my large language model. Okay, now let's first of all test it whether it is initialized successfully or not. So here I'm giving one prompt. Please provide a concise summary of the book of Harry Potter. So it should give me the summary. So guys, as you can see, we are getting the output. That means my LLM has been initialized and it is working fine. Now let's do some question answer with my LLM. The data we have given, like the website we have given. Okay, so from the website we can ask any kinds of question. Now first of all I need to import this retrieval QA. Okay, this function. Now here this is my query. Like I'm just asking how good this Vicuna. Okay, so there is another website actually. I think you remember. This is all about Vicuna. So I want to ask something about Vicuna. Okay, from this website. So it will give me the response, okay, with respect to that. Now this is my question. Now this is my query. If I perform something called similarity search on top of my vector db, so it will give you three different results. As you can see, I think I already discussed this thing, like similarity search, how to perform. And now let's say if you want to get the actual results, okay, actual results with respect to your questions, so you can take the help from the LLM. So that's why you need to call this retrievable QA, and here you need to initialize the LLM chain type and retrievable. You need to give your vector store object here, okay, and as retriever, so it will, so basically it will refer your vector database, and it will also take the query, and it will understand the query with respect to that. It will also understand the question you have asked, okay, the documents response you got, then it will give you the authentic results. Okay, now let me initialize this one. Okay, yeah. Now I will ask the same query, like how good this Vicuna. Now if I ask this query to my LLM, see, it will give you the answer. So guys, as you can see, it has given me the answer. Vicona is a chat bot that uses stable diffusion 2.1 generate the response while its quality is high. Okay, it is giving this response. Now I'll ask another question, like how does Llama 2 outperforms than other model? Let's see. Because if you see here, I have another website of Llama 2. So this is the Llama 2. Okay, so I'm asking uh, the question with respect to that. Okay, so this is the power of this LLM, and we can create these kinds of generative AI application with the help of this Llama 2, Pinecone, and LangChain. See guys, Llama 2 outperforms model benchmark. Okay, so it is giving like GPT-4 PAM2. Okay, basically, yeah, this is the response it is giving. Now let's ask another query, like what is stable LM. Okay, I think again, if you see, like I am also passing one question with respect to other website. See here, you can also add your custom website. You can ask any kinds of question with respect to that. See, this is the response I got. Now you can create one while loop, like ask the question repetitively one by one. So now it will ask for the user input. Now here I will ask one query, like what is MPT7B. So I think you remember we have one website of MPT7B. Okay, now let's ask one query on top of it. So yes guys, as you can see, I got the answer. MPT7B is a 7 billion parameter language model developed by LLM Foundry. Okay, it is giving all the answer. Now you can ask any kinds of question you can give. See again, it is asking for the prompt. So I won't be asking, I'll just write exit. So it will exit my code. See, here I have written the logic. So yes guys, I hope you got it, like how we can implement these kinds of beautiful generative AI application with the help of Llama 2, Pinecone, and LangChain. Okay, so this project actually you can also convert to Streamlit app. In future, I will also show you how we can convert it to Streamlit app. Okay,